morning everyone, hope you all safe with a good health. With you Ms. Dina Al-Badri, physics teacher for grade 12. Today we will start the first chapter in quarter 4, chapter 20. It talks about electricity, static electricity. In this chapter we will talk about the behavior of the electric charge and analyze how this charge interact with matter, and examine the force that act between electric charge. Okay, in section 1 we'll talk about electric charge. In section 2 we will talk about electric force. Forces both attractive and repulsive, and we will recognize the charging in the separation of electric charge. Describe the difference between conductor and insulators. Okay, how the electric charge is discovered. In 1752, the string. As the thunderstorm approached, the low rates of the kite string began to stand up and repel one another. And when Franklin brought his nickel close to the key, by the way, nickels, it means part of his fingers, he experienced a spark. So electric effects produced in this way are called static electricity. So when I feel a spark, small spark, we call this static electricity. Electrostatic is the study of electric charge that can be collected and held in one place. So what is the meaning of the electrostatic? It's the study of electric charge that can be collected and held in one place. Have you ever made these experiments? Yeah, when you wrap a ruler in your hand on a piece of wool, and approach it to small paper. So what you find, the small paper will attract to the ruler. You will recognize the attraction of the bites of paper to the plastic ruler. You will recognize the attraction of the bite of the paper to a plastic ruler shown in this figure. Okay. There must be a new relative strong force causing this upward acceleration, because it is larger than the downward acceleration caused by the gravitational force. So we know there is a gravity which attracts all the body to the center of the earth. So the electric force must be more than the gravitational force to make the pieces of paper to attract upward or to accelerate upward. Okay, so the electric force in this case bigger than the gravitational force. A microscopic view of charge. Electric charge exists with an atom. In 1897, Thomson discovered that all material contain light. Negative charge, all material which contain light have a negative charge particle, and he called this electric charge electrons. Okay, so who discovered the electrons? Thomson. Between 1909 and 1911, Rutherford is a student of Thomson from New Zealand. He discovered that atom had a massive positive charge. Okay, so Rutherford discovered the nucleus, which contained proton and neutron, but Thomson, he discovered the electron, which revolve around the positive charge proton. Okay, when the positive charge of the nucleus equals the negative charge of the surrounding electron, then the atom is neutral. Okay, so when the positive charge of the nucleus equals the negative charge of surrounding electrons, we call this atom is neutral. With the addition of energy, the outer electron can be removed from atom. Okay, so the outer electron, when we give this An atom emitting electrons has an overall positive charge, and any matter made up of this electron atom is positively charged. So we know that the neutral atom contains positive proton, negative electron. So when the atom lose electron, the number of positive charge increase, so it will return to P, positive charge. The freed electron can remain unattached or become attached to other atoms, resulting in negatively charged particles. Okay? So, from a microscopic view, acquiring charge is the process of transferring electron. If two neutral objects are wrapped together, each can become charged. For when a wrapper and wall are wrapped together, electrons from atom on the wall are transferred to the wrapper as shown in the figure below. Did you see here? So when I bring a piece of roots, hard wrapper roots, and start to wrap a piece of wool, what will happen? Electron from, did you see, electron from a piece of wool are transferred to the wrapper root. Okay. The extra electron on the wrapper results in a net negative charge. The electron missing from the wool result in a net positive charge. Okay. The combined total charge of the two objects remain the same. Charge is conserved, which is one way of saying that individual charge never are created or destroyed. So the charge, like the matter, like the energy, never created or destroyed, which is one way of saying that individual charge never are created or destroyed. All that happen is that the positive and negative charge are separated through a transfer of electron. A process inside a thundercloud can cause the cloud bottom to become negative charge and the cloud top to become a positive charge. In this case, charge is not created but separated. Okay, like the thundercloud, so it can be separated to positive charge. A cloud bottom become bottom negative and a cloud top to become positive. So positive cloud at the top, negative cloud at the bottom. So what is the difference between conductor and the insulators? Hold a plastic rod or comb its metal point and rub only one end. You will find that only the rubber end become charged. In other words, the charge that you transfer to the plastic stayed where they were put, they didn't move. A material through which a charge will not move easily, we called it an electric insulator. Okay? Glass, dry wood, plastic, clothes, and dry air are all good insulators. So the meaning of insulators, a material through which a charge will not move easily. Okay? Suppose that you support a metal rod surrounded by insulators. If you then touch the charge comb to one end of the metal rod, you will find that the charge spread very quickly over into rod. So, a material that allows charge to move about easily is called an electric conductor. Okay, so when the charge move easily, move quickly, we call it a conductor. When the charge moves slowly, can't move freely, we call it insulators. Electrons carry or conduct electric charge through the metal. Metals are good conductors because at least one electron on each atom of the metal can be removed easily. Air is an insulator. However, under certain conditions, charge moved through air is a fit to wear a conductor. The spark that jumps between your finger and the door knob after you have rubbed your feet on a carpet discharges you. In other words, you have become neutral because the excess charge have left you. Similar, lightning discharges a thundercloud. In both of this case, air become a conductor for a wave of a mob. What will happen if you wrap two identical plastic rulers with the woolen clothes and bring them together? What will happen? The ruler will attract each other. The ruler will repel each other. There will neither attract or nor repel. The ruler will partially attract and partially repel. The answer will be number B. Both the ruler get electric charge after rubbing with woolen clothes because they were prepared in the same way. They must have the same type of charge, so they will repel each other. Okay, question number 2. Which of the following statements about charge is true? Charge are created by gaining electron. Charge are destroyed by losing electron. Charge are separated through a transfer of electron. Charge cannot be created, destroyed, or separated. So the answer will be number C. Okay, this is the reason if two neutral objects are rubbed together, each can become charged. For instance, when a rubber and wool are rubbed together, electrons from atom on the wool are transferred to the rubber. The extra electron on the wrapper result in a net negative charge. The electron missing from wool result in a net positive charge. Okay, so after that all that happen is that the positive and negative charge are separated through a transfer of electron, like the thundercloud. Okay. Question number 3. A negative charge is generated in a wrapper root by wrapping it with a wool. When two materials A and P are brought near to the wrapper root, material A is attracted to the root, where material P is repelled. What can you say about the charge on the two materials? A is a positive while B is a negative. Both A and P are negative, or both A and B are positive. P is positive charge, A is negative charge. Which one is correct? So the answer will be A. Okay, that's all. Hope you all understand. Next time, inshallah, we will talk about section 2. Please check your LMS and print the worksheet and start to solve. Thank you.